let's create an interface called shape. So we do here plus, and the directory is chapter 9, and here we call shape. And you can see that every time by default they think we create a class. So class interface is like a class, except we change the name to call interface. Okay. So it's public. Instead of a class, we call interface. And we gave a name of the interface called shape. Inside the interface, we don't have method body. We just list the method headers. So for example, for shape, all shapes have area. So we'll say area is a double. Okay. So it's a method that will tell us, given the shape, what the area is. And also interface, every shape has a parameter. Let's just give this two. So this is the interface. How we create an interface, we say public, and then using interface as a keyword, give the name of the interface, and then inside the interface, we listing the method headers. It's a public method, and only the header. We don't have any of the body, so we don't have beginning and end of the message. So this is it, and sometimes we call those methods abstract method. So it's basically just give a name and the return type of the method, and doesn't really have anything about how we're going to calculate the area. Because if you just give me a shape and you say what's the area of the shape, and we don't have a formula for a shape. Now let's create another class called circle. And we know how to calculate area of a circle. And so we will using the name, the header of the shape. Okay, so that every shape, when we want to calculate the area, and we all return area, instead of one says calculate area, another one says get area. So we all just call area. Now for circle, we will have one attribute, private, double, and the radius. Okay. And we'll just use R. And we will have public constructor and circle, and we'll ask for a user gave input, and we'll say this R equals R to initialize the radius of a circle. And since we implement shape, that means we have to write the implementation of two methods. So one is area. How we calculate the area is pi and r squared. So we'll return math.pi times, okay, r times r. So we can just do that. Okay, so this gives us the area. And for the parameter, and the formula is 2 times pi times r. Okay. If I do that right, return parameter math.py. So what was wrong here? Expecting a semicolon. I do have a semicolon here. Oh, I'm missing the parentheses. Okay. So the implements shape. So that means we have to write the detailed implementations of how to calculate area and how to calculate parameters. And the interface here, it gives us the kind of like a superclass, and we will all implement our own methods. So if we create another class, rectangle, and we'll call this public class rectangle, and rectangle have its own we'll have double, and we'll have length and private double width. Okay. Constructor, and we can just call, we'll give to length, width. Okay. And we'll initialize this star length equal length, this star width equal the given width. Okay, that's constructor. And we want to calculate the area and the parameter. So we'll implement shape. And that means we're using the common headers and return double area. How we calculate the area of rectangle is length multiply the width. And how we do parameter is we will return 2 times length plus width. All right, oh, I'm missing semicolon here. Okay. So we create 2 kind of like a subclass, and both of them is a shape. Okay, so rectangle is a shape and circle is a shape. So the relationship is that shape is like a superclass, and rectangle and circle, both classes, are implement shape, and they have a common method, but the inside implementation, how the method gets implemented, are totally different. Totally different. So this is sounds like a polymorphism. We talk about it, right? So how we can use the interface here, and let's create a test, and will be a like shape, okay? And here, public, and we have a main method because we want to return, we want to testing it. And so we can create a shape. Let's create an array of shape, okay? So we'll call shapes equals new shape. Let's create 3 of them. And then we'll call shape 0 equals to mu, we'll do a circle. And let's give the radius 4.0. Okay. And we can have second shape equals mu rectangle, and we'll have the length is 3.0 and then 6.0. Just say that. Rectangle equals mu. And then let's have a shape 2. The last one equals mu. And we can go back to circle this time, and we'll have 5. Okay. Cannot find shape. Oh, this is a lowercase. Shapes. Okay, shapes. That's my array name is called shapes. Okay, so my array name is a shapes. Okay, so I create 3 shapes. First one is a circle, second one is a rectangle, and third one is a circle. Each one of them is a shape. Is a shape. Okay, so now let's try to see how the polymorphism works. So I'll say integer I equals 0, I less than shapes dot length, and I plus plus, and let's just do system will change this. So system out, and we'll print out areas. Okay, so inside this one, and we'll say area plus, and then we'll say shapes I that area. All right, now do we know which area they are using? And that's polymorphism. Okay, so which area method they are using? Is it circle or is it rectangle? It really depends on what's the shape has been referred to. If they refer to circle, then it will call circle's area, and if it refers to rectangle, it will call the rectangle's area, and if it refers to circle again, it will call the circle area. Okay, so we can use the interface to implement the polymorphism too. So let's run this one. And you can see, oh, I get area 0 for rectangle. Let's just say about 50. So how do I know this is the right? So the first one, it's about 50. The first one is about 50 is because this radius is a 4. So 4 times 4 is a 16. 16 times 3-ish, so that's about 50. Okay. Well, something's not right here. So the area, this one is supposed to be 18. So we don't know why this is actually says 0. So this length is the length, and width is the width. So we'll return length times width, and that is correct, right? So new rectangle, and we have this one here. That is, so let's try to run one more time. Huh, very interesting. Okay, where did I got some things not right? This is implement shape. So double length here. This is run width. Okay. So this is run. I have an actual one here. So this is like width equals width, which is 0. So that was not right. Okay, so now let's run. It's supposed to be 18. And we got it. All right. So we have a 4. We created 4 classes. The relationship, the test shape, and has the relationship with circle and rectangle has a relationship, right? And circle and rectangle is a shape. So this is kind of the inheritance. So this 2 and the shape is relationship, and this 2 and test shape is the relationship has a relationship. So the test shape has a shape in it, and inheritance only allowed to extend one, only allows. So when we do, if we change here as stands for inheritance, they only allow to have one parent, one superclass only. But with interface, one thing about interface is that we can implement quite a lot of interfaces. Okay, we can so if we have like this is we specify 2D shape or 3D shape. So we can implement 2D shape, and if this is the 3D shape, and then there may be a volume calculation involved. Another thing about the interface is that the circle and rectangle, they don't really share in code. Okay, their names, okay, the method names are the same, but inside the method are totally different. So the interface just want to make sure that the headers are the same. They all call areas, but how you calculate the areas are totally different. We cannot really copy and paste the code or reuse the code. So that's about the interface.